August 19th, Monday. It was a pretty cool morning. My goals today were to address some fan programming issues. Well, they're not issues, I'm just trying to adjust things. On the left of the screen is a blue glow. That is the convection air fan. When the stove heats up, I want that fan to spin up and be running at max around 250 degrees Fahrenheit. So to test that out, I had to heat the stove up. The other thing I was testing was the level 1 control of the fire. This is when the control box has been sitting for more than 90 minutes, and it had been sitting for around 2,000 minutes. And if you start a fire, will it be able to accommodate that? These are the goals of this video. The opacity and color shift. You can tell that it took me a while to get this fire going. It was not very quick, so I'm making some adjustments in the level 1 code based on these findings. I had opacity over 20 several times. Now, when it goes over 20%, it'll go into a mitigation mode. Also, I am present in front of the stove, so occasionally I open the door, add some fuel, or add some flame with a torch. I'm mainly trying to see how the fans respond to the situation. So it took about an hour and a half for temperature to go up. Oh, see, I didn't even transition that over. Let's try this again. This is the opacity and color shift. I tend to plot these together because they're the same magnitude. It took me a while to get this fire going, and that is because I was using the level 1 control. After 90 minutes, the control system goes into a level 1 control where it mainly puts as little air as possible into the wood stove. I want it to be able to accommodate a fire if a fire is set in the wood stove, and I'm not sure the programming was correct for this situation because it took me an hour and a half to get the stove up into the burn zone, or this Goldilocks zone. So I'm working on that. I plot the two together because they're the same magnitude and you can look at them. We had a little bit, quite a bit over 20% there. And then when I finally got the stove going, it drops down to 0. I always try to track my LED temperature because that's the light source that calculates the opacity. I try not to let it get over 150. That's an arbitrary number. However, something I tend to always say is for every 10 degrees C, it doubles the chemical reaction rate. And this appears to be a good run in the summer sun. It was cold in the morning, 53, but by the time 2 hours came around, the sun was beating on the octo-ring pretty hard, so that contributed to the temperature. It's also about the time the stove peaked out. These things happen. However, the temperature seems to be in line. This chart shows the stove temperature. It's pretty clear. We didn't really get up into the burn zone till after an hour and a half. That's due to some programming on the fan, and I'm working on that. What really shows here is that the convection fan needs a few more steps in it. It's running at 0 for a while, and then it steps up. It's a 2-stage fan, so it doesn't get the second stage going until right around hour and 45 minutes or so, just before 2 hours, which is fine. We don't want to start pulling heat off the wood stove until it's in the Goldilocks zone. The other thing I wanted to see is does the fan ramp down as the stove cools off? And it appears it does, but I want to put a few more levels in so that it is a little more graceful in that area. And the convection fan is programmed completely different than the combustion air fans. The ROR, or rate of rise, clearly shows that the control system, or whatever fuel I put in, didn't respond well till about an hour and a half into the run. However, the peak is around 20 degrees per minute, and that's about where I like it to be. It just shows that, I don't know how to light a fire, and that's evident in the data. This is the point in the video where I kind of babble and ramble along. This is the point in the test where the blue fan, the one with the blue LEDs on the left, was running just about at maximum, pulling heat off the stove. It pumps air to the back of the stove and on a metal jacket on the back, exiting on the top of the wood stove, and generally pumps hot air into the room. I like it to be running when there's 100-degree air coming off. That's pretty much my heating air temperature. Is I want the air coming off the wood stove to be 100 degrees Fahrenheit or more. And I'm making some adjustments now to the algorithm so that it can accommodate a fire placed in without resetting the system. If you reset the system, it'll start out with much more air for the first 90 minutes. But after that, it'll put less air in. The idea being that less air means less fuel burned. As long as we have good flames, we're desirable. As long as we have heat coming off our wood stoves and we're burning clean, great. If we can go through less wood, even better. Thanks for watching.